Greetings and welcome to Lecture 6.4. We're going to discuss equations involving rational expressions. So in previous lectures, we dealt with rational expressions. We did some addition, subtraction, multiplication, division. Now we're actually going to start solving them for the variable that is in the rational expression. So how do we do that? So there are 6 total steps for solving rational expressions. One is we need to find the LCD for all the denominators in the equation. Once we find the LCD, we're going to multiply both sides of the equation by the LCD. If necessary, we're going to use the distributive property to distribute the LCD to each of the terms for each side of the equation. Third, we're going to reduce each term. We're going to combine like terms. We're going to isolate the variable, and then we're going to solve for the variable. So that's it. The only difference really is we're going to find the LCD and multiply everybody by the LCD so we can eliminate the bottom portion of our rational expression. Let's look at an example and see how this is going to work. So we're going to solve x over 3 plus 5 over 2 equals 1/2. We're going to solve this for x. First thing I need to do is multiply both sides by the LCD. Well, the LCD is 6 because I have a 3 in the denominator and I have 2 in the denominator. So my LCD is going to be 6. I'm going to multiply the right-hand side as well as the left-hand side. So the left-hand side and the right-hand side of the equation by our LCD of 6. That's going to give us 6x over 3 plus 30 over 2 equals 6 over 2. Now I can reduce. So a 6 over 3 reduces down into 2x. 30 over 2 reduces to 15. And 6 over 2 reduces to 3. Now this is just a regular equation with one variable. We can solve this by moving all the constants to one side, isolating the variable, and then solving for our variable. So I'm going to subtract 15 from both sides, leaving me with 2x equals negative 12. Divide by 2, and that will give us x equals negative 6. And I can check that. Checking my solution is as simple as what I find for x. I'm going to plug in where x was. So my original equation is x over 3 plus 5 over 2 equals 1 over 2. So wherever I saw an x, I'm going to plug in negative 6 over 3 plus 5 over 2 equals 1 over 2. Well, negative 6 over 3 is just negative 2 plus 5/2. Does that equal 1/2? Well, I'm going to use the common denominator of 2, so negative 2 equals the negative 4 over 2. Well, negative 4 plus a positive 5 is a positive 1, so indeed 1/2 equals 1/2. Let's work through another example. Let's solve for x. We have 3 over x minus 1 equals 3 over 5. Now, we can solve it by finding the LCD and going through, but you can't just look at this problem. And it is a proportion, and if my numerator equals my numerator, then my denominator must equal my denominator. I'm going to work through it the long way, but if you look at the problem as the whole piece of the puzzle, and you use everything you know about mathematics, this problem becomes very simple. This problem becomes x minus 1 equals 5. Well, add 1, so x is 6. Right? So we know what the solution is by just using everything we know about math. But what if we don't see it like that? Let's use our method to solve it. So I'm going to find my LCD, multiply all of the terms, the right-hand side and the left-hand side by the LCD. I'm going to reduce, I'm going to combine like terms if needed, I'm going to isolate my variable and solve for my variable. So my LCD is 5 times x plus 1, multiplying the left-hand side and the right-hand side by 5 times x plus 1. That gives me 15 times x plus 1 over x plus 1. 15 times x plus 1 all over 5. I'm going to reduce, so my x plus 1 over x plus 1 cancels. My 15 over 5 will go down to a 3, leaving me a 15 equals 3 times x minus 1. Distribute the 3. 15 equals 3x minus 3. Add 3 to both the right-hand side and the left-hand side to isolate the variable. Now I have 3x equals 18. Divide by 3 to solve for x. So x equals 6. That's exactly what we thought at the beginning, but we now have a strict method that we can use to solve for it. But that doesn't mean that our first way of solving wasn't a method. It was we used everything we know about math to figure out that, oh, if a 3 equals a 3, then an x minus 1 must equal a 5. Therefore, x is 6. If we want to check the solution, x equals 6, so 3 over x minus 1, does that equal 3 over 5? 3 over 5 does indeed equal 3 over 5. Let's try a little bit more complex problem. We have 1 minus 5 over x equals negative 6 over x squared. So we're definitely going to try and find our LCD. Right now I have a 1, x, and x squared. So my LCD is going to be x squared. Multiply each side by x squared, so the left-hand side and the right-hand side. You can distribute the x squared, so x squared plus 1, or x squared times 1 equals x squared. X squared times negative 5 over x equals negative 5x squared over x. X squared times negative 6x over x squared becomes negative 6x squared all over x squared. Now I can reduce using my rules about exponents. Get x squared minus 5x2 minus 1 minus 6x2 minus 2. So the exponents, I'm subtracting the exponents, ending up with x squared minus 5x equals negative 6. I'm going to bring the negative 6 by adding 6 to each side so I can set it equal to 0. Then I'm going to use my zero factor property to solve. X squared minus 5x plus 6 equals 0. So I'm going to factor it, x minus 3, x minus 2. Almost there. Solve. So we're going to solve x minus 3 equals 0, x minus 2 equals 0. Therefore, x equals 3 or x equals 2. Now I do want to be very careful because in my original problem, my denominator was the variable, right? So my denominator of my problem had the variable. I don't want that to be 0. So as long as my solution is not a 0, I'm okay. So x equals 3 or x equals 2, and you see quickly how we can check both of those solutions, and indeed both of them hold true. All right, let's solve x over x squared minus 9 minus 3 over x minus 3 equals 1 over x plus 3. My LCD is going to break down into x squared minus 9 is x minus 3, x plus 3. Well, x minus 3 is just x minus 3, and x plus 3 is just x plus 3. So my LCD is going to be x minus 3 times x plus 3. I'm going to multiply every term by the x minus 3, x plus 3. So for the left-hand side, I'm going to distribute to each of the terms, giving me x times x minus 3, x plus 3, all over x minus 3, x plus 3. Then I'm going to distribute the x minus 3, x plus 3 to the 3, which is negative. becomes negative 3, x minus 3, x plus 3, all over x minus 3. On the right-hand side, x minus 3, x plus 3 times 1 is just x minus 3, x plus 3, all over x plus 3. Now I can start reducing, getting my problem a little bit less complicated. X minus 3 over x minus 3 I can cancel. X plus 3 over x plus 3 I can cancel. So the first term, all I have is an x. For the second term, x minus 3 over x minus 3 will cancel, leaving me minus 3 times x plus 3. And that's going to equal x plus 3 over x plus 3 will cancel, leaving me x minus 3. Distribute the 3, so I'm left with x minus 3x minus 9, all equals x minus 3. I'm going to move everything to the right-hand side so I can end up having positive x's. Well, let's move it first to the left-hand side and then we'll move it over. So combined like terms, I have negative 2x minus 9 equals x minus 3. Add 9, subtract x, and I have negative 3x equals 6, divide by negative 3, giving me x equals negative 2. Now I do have to remember what was in my denominator. So as long as x did not equal a 3 or x does not equal a negative 3, then I'm okay. Because remember, if I had a 3 or a negative 3, the denominator would be a value of 0, which is undefined. I'm not going to walk through this problem step by step. You can see all the steps up there on the screen. But I do want to mention, let's think about this. In my original problem, x should not be 3 because 3 minus 3 will give me 0. So as long as my solution comes down and x does not equal 3, I'm okay. In this instance, x does equal 3. So follow all the steps one by one, work it out yourself if you need, but x will equal 3. So if I check x equals 3, I'll have a 3 in the denominator. Division by 0 is undefined. Because of this, the solution, although mathematically correct, the solution is not valid for our problem. And since there were no other valid x values, then our solution set is nothing. It's actually empty. This 0 with the slash through, it means it's the empty set. No real number can satisfy this equation. So just keep in mind, it's not that this solution doesn't exist. The solution is 3, but it's just not a valid solution for our problem. It's mathematically correct, but it's not a valid solution. It's very similar to having a negative distance. Several times when we would factor and we're talking about, oh, find the length of the side of the triangle, we'd get two values. One was positive, one was negative. Well, we could toss out the negative one because distances are not measured in negative numbers. So that's it for this lecture. Until next time, be seeing you.